Welcome to Learning with Philemon. In this video, we will be looking at the organic compounds called alkanes. Before starting, let us define the term organic, which is the topic of this playlist. Organic compounds are any compounds containing carbon. Alkanes are the simplest type of organic compound. Alkanes are a type of hydrocarbon, compounds containing only carbon and hydrogen atoms. More specifically, alkanes consist of only single covalent bonds, carbon-hydrogen and/or carbon-carbon bonds. At GCSE level, you must be familiar with the first four alkanes. Methane is the simplest alkane and has the following molecular and structural formula. The structural formula shows both the atoms and the bonding between the atoms. The prefix, the beginning of the word meth in organic chemistry, indicates the presence of one carbon atom. The suffix, the end of the word ane, indicates that the compound is an alkane. Ethane is the second alkane. Note that ethane contains a carbon-carbon single bond. Propane is the third alkane. Butane is the fourth alkane. It is essential for later topics that you remember these prefixes: meth, eth, prop, and but. Each one tells you the number of carbon atoms in the longest carbon chain. This will be discussed in more detail in later videos. All the alkanes have the same general formula: CN, H2N plus 2, N being a positive integer. Using this formula, you can figure out the number of hydrogen atoms if you know the number of carbon atoms. If you have 4 carbon atoms, N is equal to 4. To calculate the number of hydrogen atoms, you multiply 4 by 2 and add 2. If there are 4 carbon atoms, there must be 10 hydrogen atoms. This is the molecular formula of butane. Now let's take a look at the reactions of alkanes. Alkanes are generally unreactive due to the strength of the carbon-carbon and carbon-hydrogen bonds. Their low reactivity can also be explained by the low polarity of the bonds, but this is discussed further in the IB A-level videos. Remember that in a chemical reaction, bonds are broken and new bonds are formed. If bonds are strong, it takes a lot of energy to break them, and reactions are less likely. However, alkanes are used as fuels. For more on the use of alkanes as fuels, watch the next video. Alkanes undergo combustion reactions. In complete combustion, there is an excess amount of oxygen, and carbon dioxide, CO2, and water, H2O, are formed as products. Note that for this reaction to occur, heat is required, for example, the flame of a match. This reaction is exothermic, and therefore produces more heat. In this particular reaction, ethane is reacting with oxygen. For more on balancing these equations, please watch the balancing equations video. In incomplete combustion, there is a lack of oxygen. Carbon, C, and carbon monoxide, CO, are formed instead as products. Note that you may see reactions in which only carbon or carbon monoxide is formed. It is also possible for carbon dioxide to form alongside these products. The amount of each product will depend on the amount of oxygen available. Both these reactions can be seen when using a Bunsen burner. A gaseous alkane, primarily methane, flows through the tube exiting the Bunsen burner. When you light a match next to this gas, you are providing the heat to start the combustion reaction. A blue flame is formed when complete combustion occurs. A yellow-orange flame is formed when incomplete combustion occurs. This yellow color is due to the heating of the carbon produced. For more on why elements emit light, watch the emission and absorption spectra video. Now let's take a look at the other reaction alkanes undergo. Alkanes undergo substitution reactions. In this reaction, a hydrogen atom of an alkane is replaced by a halogen atom. Halogens are the elements in group 17 in the periodic table. In this particular reaction, ethane, C2H6, reacts with chlorine gas, Cl2, forming chloroethane, C2H5Cl, and hydrogen chloride, HCl. Chloroethane is a halogenoalkane. This is another type of organic compound. Halogenoalkanes, or haloalkanes, are alkanes in which one or more hydrogen atoms are replaced by halogen atoms, fluorine, chlorine, bromine, or iodine. Note that this reaction only occurs in the presence of UV light, as written above the yield sign. For more details on how this reaction occurs, watch the IB and A-level radical substitution mechanism video. In summary, alkanes are compounds that contain only single covalent bonds between carbon and hydrogen atoms. They are generally unreactive, but undergo combustion and substitution reactions. Thank you for listening. To consolidate your learning, try to answer the questions in the description. If you haven't already, please subscribe for more content. Stay curious.